Um, so I'm here from Encore and Leap, and we are building a vibe coding platform and more generally like a software development platform for AI. And obviously, everything that we just heard about is critically important. And I want to share a bit about our perspective on how to solve that problem. So, what does it mean to be a vibe coding platform for developers? Um, we set out to build something that is really for full stack applications, not just the front end. It's for real world applications, not toys. It's for developers, it's for startups and teams. And if you are familiar with using Claude Code, for example, you might ask it to, hey, can you make me a sandwich? And who would think that this will go off and make you a sandwich? Hands up. Yeah. No one, right? I mean, you might try harder and it's still not going to work, right? And this is because AI does not have the capabilities to interact with the real world. If you try to instead have it do something that sort of, I mean, if you've used these tools, you know they're pretty good at writing code. But if you're building real world applications, much more goes into it than just writing code. You might ask it to, hey, I want to create a new backend service, and I want that backend service to use a database and receive PubSub messages, and then take those PubSub messages and send them to an LLM, and then take the result, make an API call back to another service, summarize it, and update the UI. Who would think that you can just like one-shot this with Claude Code in your production application? So this is the problem, right? Like this is not very different from making a sandwich because the agent does not know how to interact with the cloud or your infrastructure. It's just really good at writing code. And that's like a big difference between writing code and real world software engineering. So how do we bridge that gap? That's what we built with Leap. So I'm gonna take this and I'm gonna take exactly the same prompt and I'm gonna put it into the chat and we'll see what happens. In the meantime, before we kick this off, what this application is, it's a chat room. So let's say we want to do a chat room. I'll create that. I'll call myself Andrea and join it. And then look, there's a QR code. So if you want to chat with me while we're doing this presentation, just join in. And we'll see if we can make this happen. So I'll take this off the screen in a few seconds. So if you want to chat, this is your one chance, one opportunity. Okay. People are talking. That's great. I'm going to kick this off, and we'll see what happens. So what you can see here is this will then sort of go off and do its thing. You've probably seen tools like this before, right? It will read code, it will read documentation, it will create backend services, it will create infrastructure, and go on its merry way. And this is remarkably different from just your everyday experience because it actually knows how to interact with cloud infrastructure. So while we're waiting for this to happen, the rest of the interface is very similar to other sort of tools you've used if you've tried vibe coding tools. But this one is actually interfacing with real infrastructure. So we can go into the infrastructure tab, we can find the database, we can find here the AI engineering database row. I'm going to copy that, enter it here, and join that way. So great. Now we have this. So now you can talk with each other. That's great. So besides just databases, there's PubSub, there's cron jobs, there's object storage, there's caches, you name it. There's also API documentation. There is service catalogs. You can interface with all of this stuff. And so it's really designed, if you're a developer, it's designed for real world use cases beyond the simple front end. So we'll give this another minute and we'll see if it comes up with a sort of topic of conversation summary backend service. And while we wait, let's move on. So like we talked about, how is this possible? It's possible because we've built an open source framework called Encore. And what is unique about Encore is that it's designed for sort of cloud native backend development. And that means that the framework itself declaratively lets you define sort of databases and PubSub topics and backend services and secrets and all these things. And when you make them available in the code, it turns out that the LLM can itself reason about infrastructure all of a sudden, because the infrastructure is a part of the code itself. So that means that when you then say, hey, I want a PubSub topic, the LLM can actually create a PubSub topic all of a sudden. So just by making these concepts available in the source code, we add those capabilities to the LLM to be able to interface with real infrastructure. And so this is super important because, as we've seen, like most real-world software engineering actually involves interfacing with infrastructure in one way or another. It doesn't help you that it will just write code. If at any point you need to make an API call, the LLM will get stuck. If you need to query a database, it will get stuck. If you need to interface with anything, it gets stuck. And this is a big part of the sort of friction of using LLMs to build distributed systems. So the way this works is very simply, you can just declaratively directly in source code define sort of databases. You can define PubSub topics and cron jobs and secrets and more. And what then happens is Encore, the framework, will then parse the source code and just build up like an understanding of all of the different parts of the system. And what that means is, let's see if this is done. So now we can see that this has actually created a new backend service called Insights. And there's a PubSub topic called Chat Message, which is then being published from the chat service. So this reflects exactly what we had in mind when we said, hey, create a new service, send some PubSub messages, make API calls back, and so on. So let's see if this works. And now, if we look at the logs, this is always fun with live demos, we can see that, hey, there's no API key provided. So we need to add that. So we'll go into here, and let's see. So it's been, so while we wait, the power of this really comes down to, okay, now that we have a system that describes all of the infrastructure we need, what can we do with that? So you can do things like, okay, I'm just going to write, and then with one line of code, or one command, you can just spin up a whole distributed system and create architecture diagrams and API explorers and observability like distributed tracing and API documentation and so on. And that's really the key to how Encore works. And so besides just, okay, now that we have an ability to describe a distributed system directly in code, like how can we actually use that to do something useful? And so for the rest of the talk, we're going to look at like, okay, how does Leap actually work? And of course, we get a build error. There we go. Topic of conversation, existence and sandwiches. Great. So got over the few humps, and now we actually have an LLM that is processing every message that is being published and can update and sort of summarize the topic of conversation. So if we move on to something else, it will then sort of summarize that again and update the topic. Life and sandwiches. There we go. So how do we make this work? How do we sort of take what previously was very difficult and make that a tractable problem? So in short, like how does Leap actually work under the hood? And this is where it gets into like, okay, what are the challenges of building a platform like this? Besides the sort of, okay, we have a framework that does cloud infrastructure things, right? How do we build Leap itself? And everyone knows at this point how to interact with LLMs. That's maybe not the interesting part. I think what is more interesting is like, okay, how do you actually make this scale? How do you make this work in real time? How do you build real-time collaboration? And so what we settled on, and now we're getting much more sort of in the weeds of how this works, is we've essentially designed so that every single application that you're interacting with, if you open up the here and you, I'm sorry if this is very small here, but on startup it opens a WebSocket, and in this WebSocket you have a lot of messages going back and forth. So this is a very much like a real-time application that is then sending everything that's happening in the application between the backend and the front end. And to make this work in like a multiplayer fashion, where you can have multiple people working at the same time, all of these messages are being sent to a single backend process. So we have a bunch of servers that are running over here. So we have a bunch of users, and they are using the product, and that all of that goes to a WebSocket gateway. And that WebSocket gateway is then a stateful load balancer. So we have a bunch of different backends, and they're all running. And actually, let me open this up here. We can actually zoom in. So this will actually then look and say, oh, this project that I'm working on, this application, that's actually hosted on server number 5. So everyone who's working with this project, all of those WebSockets are routed to server number 5. And then this server is then building one giant sort of state machine where all messages are being put on a queue. So it's all linearized. And then whenever anyone interacts with the application, it gets put on the queue and then processed. And then we take the outcome of that operation and send it back to everyone else so that everyone has like a synchronized view of the world. And then that's sort of dealing with the user interface part of this application. But then when it comes to like, okay, how do I actually run this thing? You know, we're all talking in this chat room. Like, how does that work? For that, we are actually have a different cluster of machines which are running Firecracker virtual machines. And Firecracker is the technology behind AWS Lambda. And it's basically a very sort of resource, it's like Docker containers, but more secure. And so we then spin up a very lightweight virtual machine to run a backend for this application. And then inside of that virtual machine, we're running like all the different components that are necessary for this project. So we're running the front end, we're also running the back end, we're running Postgres if that is needed, we're running PubSub if that's needed, we're running object storage if that's needed. And all of these are then stored on disk as like a disk snapshot. So if we then need to move this to another machine, we can take that snapshot and sort of migrate it to another machine. And this is the thing that people who are actually using the application, this is what, if you use the QR code, you're coming in from here, you're hitting our CDN, which is then routing through to Firecracker, routing through to the actual virtual machine that is running the code. And finally, for actual code generation, we essentially make API calls to LLM providers. That's maybe the least interesting part, I think. Sorry, I may be wrong meetup. And then, of course, this is just like, now we've just looked at like a very small, like a VM that's very different from like a production environment, right? So to handle that, we actually have an integration with Encore Cloud, which is the thing that actually does like production grade infrastructure automation. So if you want to take this project and actually deploy it to like a large scale Kubernetes cluster across like 100 nodes and things, you could do that. And you can just say like, actually make this a Kubernetes cluster, deploy it using Kubernetes in Europe Central, multiple services using Cloud SQL, and hit create, and then merge and deploy. And then this will actually set up like an actual production environment with multiple services and Kubernetes, and very scalable, very production. And that's sort of how we take vibe coding, which sort of started as like, how do we build toys and prototypes, and turn it into something where we can actually build real world applications that really sort of help you bridge the gap from idea to like, oh, I actually have an MVP that I can test with real world users, and then keep building from that. Thank you.